Let's go ahead and talk about specific types of redox reactions. So the first type of redox reaction is a single displacement reaction. This is whenever one element displaces another. So what you're going to want to do is you're going to want to look and identify what's the element, and then is it going to be more likely to behave as a cation or an anion. So the element here is chlorine. It's going to react with potassium bromide, and what we'll see is chlorine is going to most likely behave as an anion, so it is going to displace the bromide, and then we'll be left with potassium chloride and bromine. So you'll be able to predict the products. So make sure you know that chlorine and bromine are both one of those homonuclear diatomics, so they'll exist as Cl2 and Br2. Okay, so that's whenever we displace the anion. If we look at our second example here, we have aluminum plus iron 3 oxide. Well, aluminum is going to behave as a cation, so aluminum will displace the iron. So then we have iron here, and then aluminum oxide there. Then the last example, we have copper plus silver nitrate. Well, copper is going to behave as a cation, so it's going to displace silver nitrate, and we'll be left with copper nitrate and silver. For an example like this, I would need to tell you that this is going to be copper 2. Okay? So, but otherwise, you should just assume if it's one of those main group elements or anything, that what the charge that you see on your periodic table of ions is what it will be. If it's something that has more than one possible oxidation number, I will need to tell you what that is going to be for the products. Okay, the next type of redox reaction that we're going to look at is decomposition. So a decomposition reaction is whenever you have a substance that breaks into two simpler substances. So for instance, we have cadmium carbonate here, decomposing to form cadmium 2 oxide and carbon dioxide. Okay, and then the next one we have dinitrogen tetroxide, decomposing to form nitrogen dioxide. So decomposition reactions are a little easier to tell than the other ones because you have one thing in the reactants and then more than one thing in the products. Another type of redox reaction is a synthesis reaction, and this is whenever you have two or more substances that are combining to form a new substance. Not all of the decomposition or synthesis reactions will always be redox reactions, but a good number of them will. But here it should be pretty straightforward because what we'll see is you have two or more substances in the reactants going on to form one new substance that might have a coefficient greater than 1, but we'll still have two or more things combining to form one product. The last type of redox reaction that we're going to look at is a combustion reaction, and this is whenever a hydrocarbon is oxidized to form CO2 and H2O. So a hydrocarbon, let's think about what that could be made up of. Well, hydro, we would think of hydrogen, and carbon, we would think of carbon. So it's something that contains hydrogen and carbon. So for instance, in this example, we have CH4, which is methane, plus O2 yields CO2 and H2O. So notice that we have oxygen as the other reactant, carbon dioxide and water as your products, and that's what we have for both of these examples. Okay, so this is a combustion reaction. You're going to need to be able to identify these. If you are ever asked to balance a combustion reaction, what I would do is this. If you're going to balance it, the first thing you want to balance are probably the carbons. Okay? So after you balance the carbons, go on to balance the hydrogens. And then the very last thing that you're going to want to balance are the oxygens. And that's because this is going to be easier to balance because we have oxygen in the reactants isolated all by itself. On some examples, you'll actually see an oxygen in the hydrocarbon, so don't forget to count those. But in general, what you want to do for balancing these is balance the carbons first, then the hydrogens, and then the oxygens. So let's go ahead and look at a few different reactions and try to classify them. So in this first one, we have copper 2 oxide plus hydrogen yields copper plus H2O. Okay, so what's happening here? Well, we can see that the copper is displaced, and it's going to be replaced by hydrogen. So this would be a single replacement or single displacement reaction. As we look at our next example, we see that we have one reactant, H2O2, or hydrogen peroxide, going on to form H2O and O2. So this would be an example of a decomposition reaction. All right, the third one, as we look at this, we have silver plus sulfur going on to form silver 1 sulfide. So we have two things in the reactants in one product. So this would be a synthesis. Okay, so the next one, we look at that. We have C4H8 plus 6O2 plus, yielding 4CO2 plus 4H2O. So we see some sort of combination going on here with oxygen. But then what we would note is there's oxygen in the reactants, carbon dioxide, and H2O in the products. So this would be a combustion reaction. Okay, the next one, as we look at this, we have potassium plus water yields potassium hydroxide plus hydrogen. Well, we can see that the hydrogen's being displaced and being replaced by potassium, so part of the cation's being displaced. So we would call this a single replacement reaction. And then finally we have HCl plus NaOH yields H2O plus NaCl. So we can see that the cation from this first one is combining with the anion here. And then the cation from the second one is combining with the anion of the first species. So this is one of those double replacement reactions that we looked at initially. So if you're looking to challenge yourself and really want to make sure that you understand oxidation numbers, I would go through all of these examples and try to assign oxidation numbers to all of the species involved.